Okay, we start by opening the 3D model, and here we get a plan of the ground floor, and it's the shopping centre where we're primarily concerned with these sales areas surrounding the escalator in the middle. If we look in the 3D view, we can see the building, rotate it, and we're going to be concerned mostly with ground floor, first floor and second floor, so I'll remove the other floors from the view. That's these floors here. If I remove the ceiling, and we can look inside and see the large sales areas. These are the ones that we're looking at the loads for. If we go through into the TBD, we can have a look at the internal conditions that we've applied to the sales areas. So during the weekday we're cooling to 22 degrees and heating to 19 degrees. And the same on Saturday and on Sunday, and that's scheduled according to the operational hours. In the results viewer, we want to look at all of the sales zones which are in this output selection, and looking at the sum, graphical sum for the temperatures and loads, we can see the repeating pattern of a very small heating load in the morning, followed by a cooling load for the rest of the day, and that pattern repeats every day of the week except for the public holiday at the start, and that goes on every week, so the heating's insignificant compared to the cooling. So on to the first of the HVAC systems. This is obviously in systems, and we've got a CAV system here with a standard mixing box. So we've got a preheat coil and the fresh air fan, and that goes through our recirculation system as well. We've got a heat exchanger to recover some of the heat from the exhaust air, and we've grouped together all 12 of the zones that we're considering on the ground floor, so we can serve them all with a single CAV system. Simulate the ground floor. This bit's running at real time, I haven't sped it up. And now we can see the results. So I'm going to look at day 120, hour 12, and the colours here show the temperature of the air as it's flowing through, the thickness being the flow rate. So we look at the two fans there, and these are constant fans, it's a constant supply system, so the loads at the bottom are all constant. But if we look at the cooling load, then we can see it's around 70,000 watts, 80,000 watts, goes up to a peak of about 87,000 watts. I've already simulated the results for the first floor, similar, 60 or 70,000 watts, and the second floor in the region of 80 to 90,000. So all of the cooling loads on this particular day at this hour, or this particular day at all the hours of occupancy, are in the region of 60 to 90,000 watts. So we can open a CAV system now with the same constant supply fans to the zone, but this time we've got a temperature optimizer mixing box. So this is going to vary the fresh air rate and the recirculation rate to try and match the temperature before the cooling coil. That reduces the loads on our cooling coil, and we can now see that for the same hours we're getting loads of about 6,000, 12,000, 30,000 watts. Much lower than before. For the first floor, getting loads as less than 1 kilowatt, and in the region of 20 to 40,000, 20 to 30,000 for the second floor. Here are the graphs showing the overall cooling loads, and that's the total. So that's the total saving we're making by introducing a temperature optimizer.